Hello friends, today we begin with file handling in C programming. So file management in C, it includes defining and opening a file, closing a file, input-output operations on files, error handling during input-output files, random access to files, and some other functions and operations that I would be showing you in case of opening an inventory database and stuff like that. So moving on ahead, you may wonder why we need files. Why are they needed? In the unit so far that we have covered, that is unit 2, unit 3, we have seen that whenever we needed to process any data, we gave the input on a console. So when I say console, I'm referring to the black screen where you put in all your values. Alright, over there you gave input as values. For example, name of student, age, marks stored, etc. But what happens to these values, alright, after the program has finished processing it? Are these values retained or do we lose these values? Definitely, these values are processed by the C program and then we lose these values once the C program is terminated. So, what to do to retain these values? Because if we are dealing with a lot of information, just imagine if we are dealing with storing the IT marks of the students in your class for IT1 and IT2 and then computing the average. Maybe you will give 80 students input. But what if I am dealing with computing the average of all the different FEs, the different branches? Will it be appropriate for me to enter the marks every point of time and then to compute the average every time I'm running the program? No. So it's better if I store these values once and for all in a file, and then whenever I need to do any computation on it, probably I'll open the file and do the computation. So that means I am not losing the values once the program is terminated. They are stored there somewhere on my computer system. So C came up with the concept of file handling where the data given as input for processing was not lost but stored in the file even if the program was terminated. So that is exactly the reason why we are studying files. The different types of files we would be studying are text files and binary files, but my major focus will be only on text files. Binary files is converting the main file, that is your text file, in zeros and ones. So my major focus will only be on text files. To do this file handling, C gives us different file operations, or the different file operations that you could do are an analogy to the file operations which you are still doing. Maybe to create a Word file, what do? You go to the software and you say file, new, open file. And if there was already an existing file, you would go to the location and you would just open it, provided the file is existing. And once you finish all the operations on a file, whatever you want to do, you definitely close the file. So that's exactly what file handling in C is also doing. It's helping you create a new file, open an existing file, read from the file and write information to a file, and close a file. I am putting stress on the words when I say read from and write to. You always read from a file and write to a file. Remember that. To enable us to achieve those functions or operations, we have input-output functions which file handling gives us. The first one is fopen. Now this fopen function takes two parameters. Alright. So within the opening braces and the closing braces, you will have two parameters in double quotes separated by commas. I will illustrate the fopen to you, but for now you need to know that fopen is a function which I use to open a file, and it takes two parameters. The first parameter is the file name and the second parameter is the mode in which I will be opening the file. It depends on whether you're opening it in write mode, read mode or append mode. I am introducing you only to these modes at the moment. Whenever you open a file and whatever operations you have to do on it, you have done, say, there's one more function, that is fclose. This function is used to close the file. Fclose takes one parameter and the parameter it takes is the file communication link, or in technical terms it is called as the file pointer. I will explain to you what I mean by file pointer. But remember, fopen takes two parameters, fclose takes one parameter. Next is getC. GetC is a function which reads a character from a file. It takes only one parameter, that is the file link or the file pointer. For example, say that I have a file called as fe.txt. I refer to this fe.txt with a file link called as fe. Alright? In this fe, say I have one character which is stored as capital H. So if I want to pull out this capital H from my file fe.txt, alright, I will be placing the file pointer into this opening closing braces. Alright, so whatever name I use to refer to this file, that will be going into the opening and closing braces. So once I do that, I will get the character that I have placed in the file. Demonstration of this will also be given. PutC is one more function which helps us put a character in a file. PutC takes two parameters. The first parameter it takes is the character you want to put, and the second parameter it takes the file communication link you have to put the character in. For example, if you had 4 files and you have each communication link uniquely identifying each file, then you will have to be very specific as to which file you want to put the character in. For now, you may only understand that PutC takes two parameters. The first parameter is the character and the second parameter is the file in which you want to put the character. Both these parameters are separated by a comma. Next I have is getW. It is in the same analogy of getC. getC is a character oriented function, whereas getW is an integer oriented function. It also takes only one parameter, that is the file pointer. Next we have is the PutW. It works in similar lines like the PutC, but again this is an integer oriented function. So PutW is going to put an integer into the file and you have to specify which file. So PutW takes two parameters. The first parameter is the integer and the second parameter is the file pointer. These two parameters are separated by comma. Now we have one more function, that is ftel. Ftel is a function which takes as a parameter the file pointer. It takes only one parameter, and by doing this it's going to be telling us where exactly is the cursor present in a particular file. Rewind. Rewind takes one parameter, which is the file link or the file pointer. The function of rewind is to get the cursor back to the starting position of the file, wherever the cursor may be. Suppose say you have written a word into the file which says hello. The cursor at the moment right now is after the character O. So in case you do rewind now to this particular file, the cursor will come and sit at the begin of the capital H. fseek is a function which I will illustrate and then explain to you towards my later programs. So let's come to how we define and open a file. So defining and opening a file. If we need to operate on files, we must specify the file name and the purpose. So when I say file name, it could be any name which you give to a file. In this case, for example, I take it as student is the name of my file. The .txt is the extension of the file. It could be .txt, it could be .pptx, it could be .doc, or it could be .docx. In this case, we'll have to specify what is the data structure. Since we are dealing with files, the data structure is the file itself. And you also have to specify the purpose for which you are opening the file. Maybe it could be for reading purpose or it is for writing purpose. So how do we declare a file? So you will open up your editor and put in your header file. Your header file is #include stdio.h, and then you're going to have your void main, open curly braces, closing curly braces. Whenever you declare a file kind of a variable, you need to specifically put it as a capital F, capital I, capital L and capital E. All file kind of variables are declared with the word capital F, capital I, capital L and capital E. Then you place a space and put a pointer. The star which you see over here is a pointer, and any variable name or file communication link which you want to associate with the file that you will be using needs to be placed here next to the pointer, and then you terminate it with your semicolon. So over here, the point that we are using pointers is, by making use of a pointer, we are actually going to the content of that, to the memory space and making changes over there. So whenever you close the file, you will see the contents that you have put exactly at that memory space. So you are actually intruding into that memory space and making changes in there. Therefore, the value is not going to get lost once you close. The value is always going to be starting at that memory space where you have declared the file. Therefore, the concept of a pointer. And since we are dealing with a file, it's a file pointer. Now this word that I used, FP, it is any valid identifier that I may choose. It can be FE, it can be FT, it can be anything, any valid identifier name. Alright, so I hope I'm clear with declaring a file. This line over here focuses on declaring a file. So going on a little bit more, the star FP that you see, it declares a file variable FP as a pointer to the file, and this pointer contains all the information which serves as a communication link between the system, that is your computer system, and your C program. See, try to understand that you have a C program which you are running on an editor, alright, on an IDE. You're trying to open a file, could be a Word file or a text file, on your computer, alright. There has to be some communication happening between your C program and the computer system. So this star pointer, that this is a star, that is a file pointer, is going to be serving as a communication link between your C program and your computer system. Getting my point? Alright. So let's move ahead. So how do we open a file in a